Welcome to our studio guests today and to fellow travelers out in cyberspace, thanks to that non-stop stream of zeros and ones. My name is Peter Gobetz, co-founder of the Zero Project and moderator of the International Conference/Workshop on Zero. The Zero Project is a three-stage affair. There's a book project, an associated online event, and the in-depth research program to follow. Today, session number 23. Professor Marcis Auzinsh, former Vice Chancellor of University of Latvia and present head of the experimental physics at the University of Latvia. He will consider the modern-day significance of zero in cutting-edge quantum physics. And Professor Kaspars Klavins, International Institute of Indic Studies, also University of Latvia. He's a specialist in Middle Eastern history, Islamic civilization, East Asian and Korean history, culture and spirituality, medieval history, and Baltic history. He will offer us a critical view of the possible connection between zero's emergence in India and the prevailing Buddhist philosophy of shunyata. Our panelists appeared in earlier sessions. Professor C.C. Roy, Nias, Bangalore, India. Professor Puneet Bindlish, Assistant Professor in Spirituality at the Faculty of Religion and Theology, Vrije Universiteit Amsterdam in the Netherlands. Professor Mayank Vahia, formerly with the Tata Institute of Fundamental Research in Mumbai, India. And Indologist Dr. Victor van Bijlert, also affiliated with the Vrije Universiteit Amsterdam. Dr. Marcis, sir, please introduce yourself briefly and tell us a little about your article contribution to the monograph on zero.
First of all, I would like to thank colleagues for inviting me to speak in this distinguished company. As Peter said at the beginning, the main goal of the project is to research how zero appeared in mathematics, philosophy, and also in physics. Probably my contribution will be a little bit different. I will try to explore how idea of zero, notion of zero contributed to the modern physics. Mainly I will be speaking about quantum physics, but probably a few words will be said also about special relativity. And if we are thinking about zero, how it contributed to physics, I think that good starting point is to start this discussion from notion of zero, how it appeared in India. Of course, I don't pretend that I'm specialist in history and do not know all the details how zero appeared in mathematics and philosophy. But as far as I understand, some ideas about zero already existed before zero appeared in Indian culture, in Babylonia, even in Maya culture in Central America. There was some ideas about zero, but in these cases it was more like a technical notation, how to indicate in different papers, like even accounting papers, the empty position. When we are coming to zero, how it was understood in India, it's much broader. much kind of philosophical idea about zero, and closely related not only to the mathematical, I would say, technical zero, but also related to feeling or a notion of nothingness, nothing, notion of void. And of course, it directly leads to ideas how this zero can be related and what kind of implications it has on kind of practical physics. I mean physics which is not theoretical, physics which is not just construction, theoretical construction, but which is kind of very directly related to a physical, real world. And if we are thinking about zero in physical world, of course, it's we're starting from this idea of zero, but it directly leads to notion of nothing. If there's zero, there's nothing, emptiness. And if we are coming to physics, so probably if we are thinking what empty space means in physics, it's vacuum. And my talk today will not be focused on vacuum, but it's kind of one of first relations between nothing, emptiness, which comes to mind when we are thinking about relations with zero, nothing, emptiness, and physics, is vacuum. Because initially vacuum was understood, initially I mean in 18th, 19th century, like empty space. And what we mean by empty space, this region in space from which we evacuate all the matter. There's no matter left in some region in space. Then it came, physics came to understanding that if we are evacuated all the matter, it's still not the empty space. There's still a lot of fields, electromagnetic fields, gravitational fields, there's still not empty space. Then we can imagine that we are taking this region of space somewhere very far from all sources of electromagnetic radiation, from all the sources of gravitational field, masses. Will we have empty space? And this is one of the similarities between nothingness, zero, and physics, which is rather explored already. And now physicists think that actually, even in that case, there will not be total emptiness. There is Heisenberg-Uncertainty relations, and I was advised to use minimum number of formulas, but some of your formulas still will be in my presentation. And what this simple formula on the bottom of my slide means, it means that if we are taking very short time periods, delta t is very small, then to have multiplications between delta energy, a small portion of energy, and short period of time, it's always will be larger than some certain quantity, Planck's constant divided by 2. What does it mean? It means that if we are looking for in very short time periods, there will be some kind of flashes, I would say, of energy, even in totally empty space. And it means that these flashes of energy, which physicists call vacuum fluctuations, always exists even in absolutely empty space. We cannot isolate space from these vacuum fluctuations. That it means that vacuum is not totally empty space. Then, of course, I know that there's experts in Indian philosophy, and there is some similarities, I would say, with emptiness, with shunyata. And I put as an example one of the suttas from the Pali canon, which from the earliest Buddhist texts. This sutta, which very directly speaks about emptiness in Buddhist terms, a great discourse on emptiness. And again, I don't want to go to the fields in which you are much greater experts than me. But we know that even in, not even, in Buddhist philosophy, emptiness also is not kind of situation when nothing exists. It's more like a lot of things exist. Only these things are not discriminated. You cannot divide yourself from the rest of what exists. You cannot find in everything what exists on any specific parts. Everything is kind of integrated and exists at the same time, and there is some similarities with this notion of vacuum. But this is kind of why I'm telling this. I'm telling this as an introduction because, as I said, we can find at least several papers when people from philosophy and people from physics are trying to examine these similarities. Peter mentioned at the beginning Jimnai Pandya, one of the scholars from India, from Haridwar, and a great friend of University of Latvia. Actually, at some point, together with Dr. Pandya, we tried to explore this topic as well. But this is, as I said, just to put things into context. And now I'm moving to the main part, maybe, of my talk about quantum physics and how idea of zero and mainly idea of nothingness influenced quantum physics. And actually, the main idea how quantum physics appeared, it was deep thinking about a transition from something to nothing. If there is a kind of physical way for transition from something to nothing. And the idea what people thought about was if there is something, and this something in my particular case, which I will be analyzing in the next couple of minutes, is energy. If there is some energy, and if we are dividing this energy into the halves, I have some portion of energy, I am dividing in two parts. Then one of these parts I'm dividing into parts again, and so on to infinity. I am dividing energy in smaller parts. And in classical physics, actually, we were thinking that finally we will be arriving at nothing. Nothing will be left when we will be infinite times dividing energy in smaller and smaller parts. Actually, as it was written in title of my talk, it remains Zeno paradoxes, probably well known, and I am sure that all of you have know the Zeno paradoxes very well. And despite that in ancient Greece, zero in sense of mathematical sense was not introduced, actually what Zeno was discussed and what he was analyzing actually was this division of something into the parts until we are arriving at nothing. And one of the simplest Zeno paradoxes, just to remind you what, as I said, probably all of you know very well, there was a story or paradox about Achilles and the tortoise. And the fastest man in Greece, Achilles was trying to catch tortoise. And of course, he's running much faster than, this is the reason why tortoise is put 100 feet ahead of Achilles. And then they are starting to run, and the reasoning of Zeno is following. Let's assume that Achilles is starting to run, and initially he must reach the place from which tortoise is starting his journey, which is shown on the second part of this picture. But in meantime, tortoise has moved a little bit ahead. Then Achilles is running to the place in which tortoise has moved in the second stage. When he is reaching that place, tortoise moved a little bit ahead again. And this reasoning we can continue and to infinity. And Zenon was telling that, look, because there's infinite many the sequences of space which Achilles should cover, and infinite many time intervals which are passing in each of these runs, then probably Achilles never will catch tortoise, which of course is paradox because we know that definitely Achilles will be catching tortoise very soon. And you can look at this paradox in different ways. One of the simple ways is to assume that, okay, Greeks simply don't know that if you have infinite series with infinite summands, the sum still can be finite value, can have finite value. But actually, I think, and many philosophers think as well, that actually this paradox is about different things. It is how many times you can divide space, how many times you can divide time intervals, and if there's the smallest portion of space, smallest portion of time, which cannot be divided further, And for many years in classical physics, physicists thought, and probably most of philosophers thought, that there is no finite last portion which cannot be divided further. And then came a year 1900, when Max Planck started to think about very simple physics problem of black body radiation. It means how radiates somebody which is heated to high temperature. We know that it's glowing, and can we describe a spectrum? What kind of wavelengths is radiated from this glowing body? And if we are calculating what kind of spectrum we will have, on the horizontal axis there is wavelengths of radiation. It unfortunately seems partially covered by some notification, but this is wavelengths of radiation. On the vertical axis is radiation intensity, and if we are doing calculations according to classical physics, we have curve shown there. If we are thinking what this curve is predicting, it appears that it's predicting very strange thing, which people in physics are calling ultraviolet catastrophe. Because if we are coming to shorter wavelengths, this curve is going to sky, let's say, and smaller wavelengths mean somewhere here is visible light, then there is X-rays, gamma rays, and the intensity is growing. If you are going from visible light to X-rays to gamma rays, and it means if this would be radiation of any heated body, it means that the space will be filled with gamma radiation, and it's obvious that probably the life in the form as we know it will not be existing in this situation. What we observe in real life, in experiment, is this kind of not exactly bell-like curve, but something with maxima here in the visible region and then diminishing to the X-ray region and gamma region and so on, something totally different. And it was kind of puzzle because people thought at this time in 1900s that we know physics pretty well. There's no secrets left. But we have this absolute strong contradiction between theory and experiment, which is coming from real life. And then Planck solves this problem, and solves in an interesting way. Actually, he divides this incoming light energy to infinity, to infinite many times. And if we will be able to do that, then we are arriving actually in this classical curve and arriving into the contradiction, which should be somehow solved. And what assumed Planck, that no, he said, there will be finite number of divisions, and then we will be arriving at smallest portion of energy, quanta of light, in some sense contradiction to our intuition that energy is something which can be divided as many times as we wish. He wrote this smallest portion of energy as Planck's constant multiplied by frequency. I will not be going to details. And actually, if we have this type of smallest portion of energy, it has very strong consequences if we are trying to calculate average energy of oscillator. And average energy of oscillator is something which this blackbody radiation radiates. There was this dots which appeared one after another. I mean that if we are taking average of all these energies, energy and probability, it's called Maxwell-Boltzmann statistics distribution. For physicists, it's obvious, and colleagues here who are from physics and from science, probably it's a kind of well-known things for them. For others, let's assume that there is some distribution and probability distribution of energies. And if we are taking average energy, we are getting again constant, in this case Boltzmann constant, multiplied by temperature of the body which radiates. And Planck suggested almost the same, only from this distribution curve, only few energies are allowed. And we are averaging between smaller number of points, but intuition would say that, okay, we have a smaller number of points, we have a larger step for averaging, but we will have something similar to what we had before. But actually, no, we have something very different. I will not be discussing this formula in details again, but you can remember that KT in the previous average energy, this little bit more complicated formula for average energy if we have this step size, smallest portion of energy. And as a result, we are arriving in energy distribution for blackbody radiation, for radiation of this heated body, which is exactly coincide with what we have in experiment. It means that actually departing from zero, departing from nothingness, departing from possibility to divide energy infinite number of times, we are arriving to results which is in a good agreement with experiment, in contrary to this idea of zero energy, which is in contradiction with experiment. For that, Planck got Nobel Prize in 1918, and I see that I am already almost overrunning my time. Very small remarks, but I think kind of interesting remarks. And I will be comparing zero with infinity, and infinity is something again related to zero. If we are any number dividing by zero, we are arriving at infinity. So we have these two notions, zero and infinity, which seems rather remote one from another, but actually closely related. And then if we are looking how these quantities, what kind of roles these quantities played in physics and in mathematics. In mathematics, when we are starting to think, and we, I mean mankind, starting to think about zero and infinity, new mathematics arrived. About zero, probably you have a lot of discussions already in this conference. About infinity, actually, also it's a very interesting and long story, which I will not be telling here, because maybe contrary to intuition, there's many infinities, and one infinity can be infinite times larger than another infinity. Mathematicians are calling this power of infinity. What I'm summarizing and trying to tell here is that when zero and infinity appeared in mathematics, new mathematics started. In physics, actually, it appeared opposite. when we departed from zero, when we departed from infinity as well, when these ideas in some sense disappeared from physics, new physics started. For example, when we understood, physicists understood that there is the largest possible speed, and that nothing can be moving faster than the speed of light, there's no possibilities to have infinite speed, immediately Einstein's theory of relativity appeared. Until that, people thought that speed can be can have any value, even it can be in theory infinitely large. There was classical physics, classical mechanics. When we understood that speed is limited and it's not infinite, that it's the largest number finite, ancient theory of relativity appeared. And as I demonstrated in quantum physics, it happened in the opposite way. At the moment when we understood that there is limits for smallest portion of energy, that there is isn't possible to have zero energy. At that moment, as I showed before, quantum physics appeared. So I think that's something, some interesting similarities and dissimilarities between mathematics and physics, what role played zero and infinity in physics and in mathematics, something to think about. This is all from me, and usually people are putting in the last slide, thank you for your attention. Of course, I'm saying thank you for your attention, but I'm putting my email address as well. So if after this discussion, which will be happening now, if you will still have some questions and willingness to discuss with me, so please write me email. Thank you.
Thank you, Marcis. Thank you very much. One question, this is not the usual routine. Questions come at the end, but I can't help myself here because it's also part of the thrust of where we're trying to head, is that not only that the West and modern physics adopt zero functionally, simply because of its utility, but by doing so, we think that with it came some unseen baggage in the form of the underlying philosophy, and through a rather complicated mechanism of, say, a reverse semiotic transmission. In semiotics, you have to develop a concept before you can visualize it in terms of a sign and identify the object with it, rather than the other way around. Realists tend to think they're objects, and we derive our concepts from the objects, but it's probably the other way around. And if that's the case, then zero, like a Trojan horse, came into the West as a functional mathematical concept, but by doing so, it enabled physicists like yourself and others, your generations before, to conceive of this concept of nothingness, which had not been contemplated earlier because of doctrinal reasons inherited from the Greeks. So that's the insight that we gained, and we wonder here from your presentation whether you could verify some of that by considering whether what you said about both the movement towards quantized energy and quantized space, whether that could be related to zero itself, or rather the concept of zero, not simply its utilitarian use as a technical issue, as you mentioned, but conceptually, that it became tenable, that without consciously being aware of it, that this is probably subconscious, that in contemplating zero, that they could think about it for the first time in a deep way, that the underlying philosophy of zero could have been transmitted in that way and permitted physicists later to consider these options, which previously had not been considered. As a long question, but I mean, the thrust of it was Was zero more than functionally adopted? Was the concept instrumental in later developments in physics?
Definitely, I think so, because probably if we are looking in the history of physics, one of the Nobel laureates, the only one Nobel laureate who has been born in Riga, Wilhelm Ostwald, actually until 1906, he was convinced that matter, chemical elements can be divided as many times as you wish, that it's kind of continuous media. I think that it's very deeply rooted, I don't know if from Greek time or in some other way, in our understanding that space can be divided as many times as we want, time can be divided as many times as we want, energy can be divided, which is kind of thing which is not something which we can touch and kind of easily see, I would say, energy. So it means that ideas that there shouldn't be limits in many things what we are doing, and division in smaller parts, as notion that there shouldn't be limits in division in smaller parts, but it is very deeply rooted in our understanding of the world around us. So it was not easy, and actually Max Planck was very much upset with his own ideas and was trying to correct his feeling about quanta all the rest of his time, his life. Fortunately for us and fortunately for physics, he didn't succeed, and it was impossible to succeed because this quanta of energy kind of really exists in physics. So short answer would be, I think that this kind of nothingness, zeros, that do not exist, smallest part of energy, matter, and things, other things in physics. When we are dividing things, was deeply rooted, and it appeared that it was kind of very difficult and painful changes of concepts and ideas when we are coming to quantum physics, and actually in similar way to relativity as well.
All right, so this will be a long-running line of reasoning argument. Eventually, we won't solve it here. And we have other physicists on board who would like to consider this. So let's leave it there for now. Marcis, thank you very much for this very enlightening presentation. Kaspars, if you would kindly take the floor and proceed with your presentation after just a brief introduction about yourself, if you would, please.
Thank you so much for your invitation, and many thanks to founder of the Zero Project, Peter Gobetz, as well as many thanks to my teacher and authority, Professor Marcis Auzinsh. And due to his invitation, I got the connection to Zero Project. My paper actually will theoretically, or not theoretically, but philosophically support in a way what the previous what was told in a previous paper. And I'm starting with the problem. The problem is that actually we have to talk first about the subject, because 90% of the clarification of the problem is if we are specifying the subject, what we're talking about. And actually, zero is being differently understood as emptiness, which is one thing, nothingness, which is another thing, equilibrium, which is totally different, again, a different problem, and borderline, when a quality changes to another quality. And that's, again, a totally different question. And I'm talking about the problematics of zero, because very important, first of all, we have to understand about what kind of zero we are talking, because under the name zero, we can understand totally different subjects and totally different issues and questions. When looking more closely into the material regarding zero, it's very important to remember that scientific revolution, if we are talking about theory that appears in a certain region and is being transplanted to another region, then certain discovery within a particular civilization only becomes a discovery after necessary preconditions have occurred for the perception thereof, as Thomas Kuhn rightly told. And only after becoming part of mainstream science of that particular time and place, provided its representatives feel the need for change. Exporting a discovery, I would say it is not possible if the recipient does not have analogy or analogous understanding of the meaning, value, and usability of such a discovery. Regarding the introduction of zero in Europe, we know that despite information about Hindu-Arabic numeral system, including zero, acquired by Fibonacci from sources in Arabic language, zero failed to gain a place in European mathematics until the 17th century. And even René Descartes, despite the introduction of zero in the center of the number line, denied in his writings the existence of emptiness. So philosophically, René Descartes was against that meaning of emptiness or nothingness. And additionally, difficulties may arise from again, if we are talking about certain philosophy and trying to make an interpretation. For example, the problem is also another big philosophical problem. We always want to associate zero with non-existence, but there are very ancient cultures that have also influenced genesis of zero, as the previous speaker also rightly told, in the European tradition as well. And there is no concept of non-existence in these cultures. Distinction must be made between philosophical meaning of zero and practical manipulations, calculations, and so on. And these are slightly different things. For example, in ancient Mesopotamia, there is no concept of zero, but the interest of a loan is calculated to the third sign until the balance equality is gained. So zero could be just used as an equilibrium. So if we are using scales, if there is a zero wave, so it's a zero, and if we put the same amount of wave, it's also zero. So it's just an equilibrium. I'm talking just from the point of terminology. From the point of Egypt, we could have both zero and division, but theoretical part is based on assumption of the starting point. And when the point is absolute and everything is taken from it. In Assyria, the starting point could be the state of stars and everything according to that. But actually, there are no negative values from the essential point of view, because material things never disappear. They change their shape, appearance, and so on. And so we are coming closer to Arabic and Farsi tradition, and also closer to Near East tradition, including monotheistic thinking, as we see in Abrahamic religions, including Jewish. Regarding that concept of zero, it is somehow different from the Hindu concept and from the Buddhist concept of zero. We are talking about zero, and we are using in mathematics both, because Hindu numerals are being used by Arabs, but the concept of zero is a totally different one, or the concept of emptiness or nothingness, or as we say. For example, if we are checking tradition following the Brethren of Purity, Ikhwan as-Safa, from the 10th century, esoteric fraternity based in Basra or Baghdad, we see that in relation to the symbolism of zero and its sources, infinite or the divine essence corresponds to 0. Therefore, symbolizes divine ipseity, which is above all determinations, including being, al-wujud. Although it is known that the Brethren of Purity were also influenced by interpretations of the achievements of Indian science, which were available to them through various Arabic sources, there is no evidence that due to their activities, the symbol of 0 would have been promoted in the mathematics used by the Arabs. Instead, Arabs seem to have adopted the 0 symbol for practical use due to the translation into Arabic of the Brahmas Buddha Tanta already in the 8th century, and due to the activities of Persian polymath Muhammad ibn Musa al-Khwarizmi, a result of which Hindu numerals, along with the notion of 0, shunyata, or in Arabic as-sifr, and that's for a 0, truly entered the science of Islamic civilization. We cannot explain religious basis of 0 in Islamic esotericism with the influence of Buddhism. Frequently misunderstood Buddhist concept of emptiness is something completely different. And I think very good and very rightly Professor Auzinsh told that also, as we see also from the point of Buddhism, emptiness or nothingness actually is not nothingness. That is sometimes wrongly understood in Europe. Of course, we can try drawing parallels with Hinduism in the context of principal Upanishads, keeping in mind that in Hindu tradition, the supreme, we may call it God, is both transcendental and immanent, although we can compare it with the Greek notion of arche, or first matter. And actually, if we are talking about ancient science, it is very dangerous to make some kind of very modern interpretation of it, because the notions could be very similar in a Greek and in Indian. Although in India we have the 0 in a practical mathematics, and that makes another question. Regardless of certain universal analogies that can be traced in many religions around the world, we cannot consider Hinduism as a source of the understanding of God in Islam. So, idea of 0 as the symbol for God postulated by the Brethren of Purity originates from the explanation of God that is acceptable to monotheistic religions, namely as neither a material nor a spiritual phenomenon, present above all that exists, which is analogous to the negative explanation of God by means of the nothingness characteristic of European Christian mysticism in medieval and early modern period. Question is, why was Islamic civilization able to accept the symbol of 0 for practical use in mathematics so quickly, unlike Europe, where it experienced extended opposition regardless of the concept of nothingness in the religious philosophical field? In other words, why was the Indian concept of 0 introduced quickly in the science used in Islamic countries or Near East, while in wider integration of 0 in European mathematics was accepted, I would say, much later than 17th century, despite information about the symbol of 0 having started in Europe much earlier in the 13th century. Initial advantage of the Middle East can probably be explained by the lack of contradiction between science and religion that became the key to the somehow also to Islamic civilization past achievements, while the strict separation of these areas was for many centuries an impediment in the Western world. Somehow also comparison of the concept of nothingness in European Christian mysticism and the concept of emptiness in Buddhism is not really possible from the essence of the question. Even if the introduction of the 0 symbol in European science, that is mathematics, took place late, it cannot be stated that it was related to incompatibility of the concept of 0 with the European philosophical religious tradition. 0 as, or let us say, emptiness, or probably also not to intermix emptiness with nothingness. These are also two two different philosophical concepts. The entire cultural history of Europe is a line of paradoxes. If we are talking about European Christian mysticism and comparing it to Buddhism in the religious philosophical context of the concept of zero, we have to think, for example, how wrongly Japanese philosopher Kitaro Nishida understood. He drew parallels between Shunyata concept in Buddhism and Master Eckhart's concept of nothing, nichts, in a German language. However, as we will see below, such a comparison is essentially wrong, because contrary to the ability of Buddhist thinkers to operate with non-defined, European thinkers from medieval times already had a tendency to precisely define the self and everything that exists, which addresses science, religion, philosophy equally. Apparent similarities between European religious mysticism and the spiritual teachings of India and East Asia in terms of form and expression do not eliminate the cardinal differences in the very approach to reality per se between these two traditions, which has been well emphasized in works of some other philosophers. For example, if we compare Master Eckhart, the most prominent representative of European medieval mysticism, and Nagarjuna, who is one of the most important Buddhist philosophers from India. Especially, we can compare the explanation of nothingness in Master Eckhart's writings with Nagarjuna's view of the concept of so-called concept of emptiness, shunyata, in a Buddhist philosophy. Master Eckhart's concept of nothingness is very often used as a negative comparison of everything existing. Everything created by God with God himself. We cannot compare. That is, in order to glorify God, being far above the world. For example, Master Eckhart, God, the intellectus, stands in opposition to being as such and can thus be qualified as nothing. It is the nothingness of being. The intellect negates being in its entirely in order to be everything that can originate at all. On the other hand, all that is created he calls nothing, also on comparison with God, who is the real essence of all things. Actually, nothingness is a matter of terminology. Master Eckhart believed in creation ex nihilo, creation out of nothing. But all the nothingness is just because on comparison with some universal meaning of God. That is an absolute entity. And nothing out of which God created the world is the divine intellect in which God designed things before he created them. Such a perception is completely different from a Buddhism, first and foremost because Buddhism is a spiritual teaching without such kind of absolute meaning as God. And as well, Nagarjuna, as it was also probably related with the previous speaker, and I support that meaning, and we see that in the philosophy of Nagarjuna. Nagarjuna understood the concept of emptiness completely differently. All things are in perpetual process of arising and passing away, ever becoming and thus never actually being. Conditioned by multiple interdependent causes, all things are empty of any sort of independent or intrinsic nature, and thus defy conceptualization. So, in Nagarjuna's philosophy, it is not nothingness as such. Nothingness as such doesn't exist. And nothingness, in a European sense, is just nothingness in comparison with God. That is everything, is absolutus. Contrary to Master Eckhart, such a position, methodologically explaining emptiness, means that emptiness itself means observing objective reality without fixing one's attitude. But in European tradition, everything is based on attitude. If everything is empty of self-being, swabhava, there are no objects with ultimate reality in this sense, and subsequently any theory of such objects is mistaken and should therefore be abandoned. This fully coincides with the traditional Buddhist perception of the unsustainability of all phenomena. So void the word therefore, because it is void of a self and anything belonging to a self. Certainly, Nagarjuna does not deny reality of the word. He merely does not accept that it is possible and necessary to objectively explain it, and likewise with the terminology of reality and non-reality. And for him, according to Buddha's example, utmost denial is a futile and extreme as its opposite. From this vantage point, shunyata follows from the interrelation of all things, which does not allow them to acquire actual independent existence, while the concept also represents reality per se in such a way that it is not possible to either be perceived or explained in rational terms at the level of common consciousness. Is it really non-existence or emptiness or non-being as such in the philosophical of Nagarjuna? No. As such, meaning of nothingness doesn't exist. Sure, it is interrelation and connection of everything, of all phenomena. Sure, as also as it was told in a previous speech. Already since the European Middle Ages, but what's the difference? The difference could be in a perception of the reality in a way, and then we have to switch to Democritus, to atomic theory, and that's extremely interesting because of the previous paper about division, about discussion whether we can divide all phenomena eternally, whether there is a certain element that is not divisible. That was already in the discussion of Democritus in Greek philosophy. But the difference between Democritus' atomism and, for example, East Asian philosophy could be that atomos has a certain shape. But, for example, as a contrary, for example, to a certain meaning of tsi, energy that is shapeless. But again, there is the danger. Maybe the shapelessness is very much connected with supreme ultimate that we see even in Confucianism, and that is very much connected with certain idea of universal mind, and that idea puts the limits to our discoveries. If we are stressing, for example, negative or nothingness as a negative comparison towards the absolute essence of God, we may liberate our mind from all the phenomena in reality that may be discovered if we are abandoning all the limits and telling that all things are interrelated and still connecting our theory with certain supreme mind. We are putting limits to our discoveries, and that is the paradox. Probably is a certain comparison with the previous speech. So the putting the limits and talking about nothingness in comparison with God and in a monotheistic sense, dividing God with the reality. Actually, all discoveries towards reality, as we see also in Islamic civilization, were liberated to all the possibilities. If we are putting reality as an interrelation of all the things, or explaining as an interrelation of all the things, that type of liberation is immediately putting limits to our scientific seeking. And that's a paradox in a theory or in a philosophy. Very much like symbolic explanation of God by means of zero in Islamic esotericism, we can see in a Flemish mysticism of John of Rusbroek, who also stressed God's total non-connectedness to anything actually measurable, writing that God is a size without measure, length without end, depth without foundation, and so on. And this is the essence of negative definition of God, similar to that provided by Master Eckhart. According to this, it is not possible to compare God with anything existent. It is only possible to stress its non-likeness to anything.
Kaspars, can I ask you to kind of conclude, because we're running over time for the other panel.
And so what I would say in a conclusion, what's the point? I think that Indian philosophy, as we are talking about India and zero, would be very, very interesting to deepen, not just in a Buddhism, but in that in the part of Hinduism, and to check it with the supreme universe, and to check whether Indian philosophy was some kind of mediator between Near Eastern monotheistic comparison or negative nothingness and the East Asian shapelessness of the universe that we see in a Chinese philosophy. That would be the uniqueness and the very interest regarding the origin zero in India. Thank you so much.
Thank you, Kaspars, and we will definitely take note of that, because, as I said, it's an open field. We're exploring options, and definitely Hinduism should be brought into it, and has been brought into it. As a matter of fact, one of our panelists who was a speaker last week, Dr. Puneet Bindlish, is focusing on that with his team. But again, we're having to juggle here a little bit, because Jeff has another commitment. He has to leave soon. We have about 10-15 minutes. So if I can ask Jeff first to respond to the two speakers, and then we'll resume our usual pattern. Jeff?
Okay. First of all, for theoretical physics, my area of research is so distant from it, it's hard to make any remark, except that what I like about physics and about pure mathematics as well is that when your theory does not fit reality, everyone knows that it's your theory that has to change. And then when you get into people talking about history and philosophy, it's not always so clear cut. So it's really nice. And that's one thing I admire about physics and mathematics. I was trained in mathematics, so that's my area originally. So I don't really have any other remark about the first talk apart from that. So I don't know.
And what about Kaspar Klavins, about the philosophical aspect? You're much better versed in that, also the Islamic.
I do have something to say here, because it's, of course, more closely related to what I'm working on. I really like the fact that you emphasize, you point out that we really need some evidence that there's a connection between the philosophical understanding of zero and nothingness and the mathematical zero that's used in arithmetic. I don't think anybody has come up with any concrete evidence that there is any connection. So that almost leads us to the possibility that we're really investigating two very interesting but possibly completely separate issues, one philosophical and one mathematical. So that I'm very glad to hear about it in your talk. And but as far as the European use of zero, you mentioned that although the zero was introduced by Fibonacci and by other people around the same time in the late medieval period, you mentioned that it did not take hold until the 17th century. But in all the texts I read, in all the medieval Italian abacus texts, in Luca Pacioli, and all of the texts from the 16th century, Arabic numerals are taught and operated on with zero universally. So I'm wondering, what is it that changed in the 17th century?
I'm still checking what happened. I can just very briefly. I'm checking what happened from the point of philosophical explanation and a relation of zero with the nothingness. And when I'm reading René Descartes, he is completely against that idea. So he is using zero, and he's always telling, sorry, it doesn't exist, but I'm using because of this. Actually, what I wanted to talk about acceptance of a certain philosophical point of zero. But then again, there are questions, what was really the meaning? Because in that moment, in the let us say 17th, 18th century, when the so-called modern science starts. As we see in the previous paper of Professor Auzinsh, everything changes again, and everything changes in philosophical discussion. But zero as a kind of nothingness, at least philosophically, was accepted, and negative numbers accepted from the theoretical or religious point of view, I would say 17th, even 18th century.
Yeah.
Not earlier. They were using, but using, as in alchemy, they were using many things that they were not accepting themselves. And only a deviation was the discovery, but discovery was actually not a result of the goal why the research was done, and so on.
Yeah. So yeah, it is true. The negative numbers, complex numbers were all worked with in a kind of formal way before they were actually accepted as numbers, beginning in the 16th century. But I don't see any difference between the use of zero in a mathematical sense from medieval Arabic and medieval and early modern Europe. So that's the only thing I was curious about. Also, Descartes, people have distorted somewhat Descartes' mathematics for easier consumption in the tertiary literature, in the secondary literature, I should say. Descartes does not work with a number line. So Descartes' numbers are measures of the length of magnitudes. He never has a line where he assigns numbers to points. Numbers are always lengths. And as such, number cannot be zero. Although formally he worked with a zero. If you look at his equations, he preferred to have a zero on one side, but that was kind of a formal use of a zero. So his La Géométrie really is about geometry specifically. He just assigned numbers to the magnitudes. And what we call Cartesian coordinates are not Cartesian, actually. They were invented later and named after him. But this is a very minor point. But overall, I agree with what you've written. So. Anyway,
sure. It was, sure. So it was, of course, that it was introduced in a center of number line at that time when you told. But yeah, that's a different question.
Yeah, I understand. So yeah, I'm just being really picky here because that's I don't know. I have this nature. But overall, I read your paper and I agree with overall. I think the main point is right on target, and I'm glad to have read it. So, but I might send you an email note about some little things just to ask you about later on. Okay. So, yeah.
Okay. So, thank you, Jeff. Okay. You're welcome to stay until you have to leave, or
I'll hang on to the last moment. Okay.
Okay. Yeah, because Jeff has a very important role because it's the latest of the civilizations that we studied, and there's very little evidence in Mesopotamia, China, and India to work with, detailed calculations. There are plenty of tablets and papyri and things, but not necessarily what we're looking for. And because the Arabs were in a later period and more inclined to write about what they did, we have much more testimony as to how they saw and worked with the then new decimal system that had come in. So Jeff is a very important link in the chain, also because he's conversant with both the more ancient Greek and the more later medieval European history. And that's actually how the Zero Project got started, because we were wondering if Fibonacci didn't understand zero to be a number, what prohibited him from doing that if he got it from the Arabs, and the Arabs had understood it. So we asked Jeff, and it turns out that Jeff did a study on that not a single manuscript that he studied acknowledged zero to be a number. They all denied that zero was a number, and then they worked with it, technically speaking, very well, but they didn't accept it as a number. And then we were wondering, well, if the Europeans got it from the Arabs and the Arabs didn't understand zero, did the Indians understand zero to be a number? And so the whole thing, the whole house of cards collapsed around our ears, because now we're back to India and China and Mesopotamia to see whether they had understood zero to be a number, or whether we in modern Europe modern world are projecting our modern views on the ancient cultures, saying that there's a distinction between zero and the number zero and the placeholder zero, whereas that may not have been the case or may not be the case, maybe an anachronism. So we're chasing that down, and in that sense, Jeff is a very important link in the chain, as are some of the other speakers who are not present today. So Jeff, thank you again for that. I will now follow the sequence that we had envisaged. Dr. Sisir Roy at NIAS in Bangalore, now in Calcutta located. You would have heard the two papers. You're an expert both in physics and in Buddhist philosophy, which makes you a very good bridge. And you have been cited in the paper that Marcis is writing. One of the references that he gives is from C.C. Roy and another author. So that made us very curious, and the reason we invited you also, apart from that, is what is your takeaway from the presentations today, Sisir?
Yeah, can you hear me?
Yes.
The presentation seems to be very good, but we have to be a little bit cautious about using philosophy like Buddhist philosophy, quantum physics, etc. Because even if we understand zero, the numeral zero, philosophically shunyata, then we have the following problems. Like in Buddhist philosophy, as well as Hindu philosophy, other schools of Hindu philosophy like Vedanta, they use the concept of shunyata in the sense that they consider two layers of reality. One is called ultimate reality, another is conventional reality. In Sanskrit, we say this is paramarthik satya. Satya means truth, ultimate truth, and vyavaharik satya means conventional truth. The issue is, in philosophy, they understand the two layers of reality. But as a physicist, I don't understand. What do you mean by ultimate reality? And what do you mean by conventional reality? How to differentiate it? So, when you compare shunyata, even in Buddhist philosophy or Vedanta, how do you compare with terminology in physics? Moreover, my colleagues, they nicely mentioned about Buddhist scholars, second century, Nagarjuna. His theory is called Pratitta Samutpada, or dependent arising, interconnectedness. But that interconnectedness or interrelation is valid in the conventional region, conventional reality. Because another Buddhist scholars and logicians, 8th century, Dharmakirti, he wrote a very interesting book called The Metaphysics of Relations. He showed that the interconnected relation, they exist only in conventional world. And in the ultimate world, even that relation is not real. And it gives rise to a lot of debates among Buddhist philosophers and other schools like Vedanta, Naiyayiks, and others. So, when we compare with quantum physics, concepts of quantum physics, shunyata, and shunyata from Buddhist philosophy, we have to be very cautious. Because
Cici, is that a question for Professor Marcis or for
yes,
for
yes.
both? For both.
Both.
For both. Marcis, could you respond to that? You understood the question?
At least partially. Yeah, of course, this is what I'm always telling, because nowadays it's kind of willingness from one hand to explain spiritual things with physics, and on other hand to tell that look, in some ancient wisdom, everything what you are doing in physics already existed. I think this is dangerous path, and probably we should look in parallels and of course compare approach from physics and approach from ancient Eastern teachings, but not to try to explain one with another. At least it's my feeling.
Oh, no, absolutely. We fully agree with that. But that issue we avoid like the plague. We're not going to get into that.
When we are coming to this conventional reality and ultimate reality, actually, I think that in physics we are also trying to think, especially in modern physics and especially in quantum physics, in similar way. Again, I wouldn't to draw very close parallels, but some similarities, because what we are thinking, for example, in quantum physics, and people from physics will understood probably me better, we are saying that there is wave function, kind of not actually ultimate reality, but something which is basis for behavior of particles which we are observing in kind of conventional reality. And in Eastern philosophies, why Western people, my feeling, why we are so much interested and sometimes kind of addicted even to Eastern teachings. We are saying that there is some ultimate truth which is revealing itself only to some people, only in some specific circumstances, and so everybody is willing to touch this ultimate truth. Why people who are not from physics are interested in quantum physics, and from my experience, I even sometimes surprised who are inviting me to speak about quantum physics. People from banks, for example, team building events, and they are asking me to come and tell us about quantum physics because people in banking are interested in quantum physics. I always ask, trying to understand myself why you are interested in quantum physics. And my answer to myself is that probably the reason for that is that there is feeling that in material world, let's say, there's also this ultimate truth which is at least partially hidden from our everyday experience. And quantum physics is thing which allows to think in this direction, and which is sometimes hard to understand. I will use one more minute. I remember one situation which somehow coming to my mind again and again. It was again some public talk, and after that, one gentleman came up to me and said, "Professor, what you was telling about quantum physics was very interesting." And of course, as a professor, I was starting to be happy that people are saying that it was interesting. And then followed the second part of sentence, but I understood nothing. And then I'm starting to think how it's possible. If I understand nothing, you don't understand anything, how it can be interesting. And the solution actually was very simple. The solution was the following. I believe if professor is telling something that probably there's some truth in that, but I cannot understand how it can be in this way. If the cat, shredding a cat, can be alive and dead at the same time, particle can pass through two slits simultaneously and things like that. I cannot, as a reasonable person, I cannot understand these things, even if professor is telling me that. But reason, I think, and then maybe coming back to your question and kind of statement, that we should be careful and cautious to make these relations. Definitely, but I think that some similarities in way of thinking that there's conventional reality, what we are observe around us, and then there's deeper meaning and truth behind that. And in quantum physics also there is this deeper truth in our theory, let's say. So there still exist these similarities, and this is why I think it's interesting to try to compare the things. And maybe very last sentence from me, I am taking a lot of time, but sorry. Sometimes, again, if we are comparing this kind of spiritual attitude to things and attitude from standpoint of physics, one of the dangerous things is that we are trying to postulate that physics is true. All the other things is something, I don't know, strange discussions, or vice versa, that you are coming from physics, this material world is much more complicated, spirituality is behind that. Let's deny physics and coming to see world only from the spiritual viewpoint. So the trick is, and probably what people, to my mind, should try to cultivate, to look from the both viewpoints simultaneously, not to try to say that one is better than another one. They are complementary. They are complementing each other. And if we are able to keep both of them, and maybe not only two, but many of these viewpoints, and to look in the world from all these perspectives simultaneously, and each of these perspectives to find some part of truth, then we are starting to understand the world more kind of broadly, I would say. This is why physics and this spirituality, we are complementary things.
No, absolutely. And in fact, that's why we are an interdisciplinary approach, because there is this danger of tunnel vision in specialism. Professor Auzinsh said, Marcis has responded to your observations. Does that? Are you satisfied with that, or do you have any follow-up to that, or for the other gentleman?
What you told is right, because you have to. Only thing what I have to say that we have to be very cautious when you compare like similarities or dissimilarities or convergence, because apparently two domains are. I mean, two knowledge systems are not completely
quite
same, right. And they're acquiring the knowledge in two knowledge systems is also different.
Well, let me then, from the standpoint of the Zero Project, emphasize that the objective of ours, is not to understand in minute detail the similarities and dissimilarities, and compare and contrast, and with the intention of finding one to be superior to the other. The intention is that since there is no research being done into the origin of the emergence of zero, and let's always remember how strange that was, that we had, the human historical record shows people counting 50,000 years ago, making tally marks on stone and bone, and then nothing happens for tens of thousands of years, until very late, when suddenly, again out of nowhere, we're still confused about how that could have happened. You have these additive systems that people devised, but you did not have a positional system, which almost implies a zero. So both of them are mysterious as to how they came about. So that was really the motivation for us to launch into this. And because there's so little evidence, we are looking in the mathematics does not evolve in a vacuum. It evolves in a cultural context. And that's why we're looking at the other disciplines, the cultural antecedents that may have led to the invention of zero. That's why we're exploring. We're making a broader swath to be able to get a better grasp of what the invention of zero might have been. So that is from our side as a way of an apology for raising the impression, perhaps, that we are trying to push one point or the other. That's why we're bringing you all together. So thank you very much for that. Puneet, you've been very patient, and you probably felt that you were being addressed when there were calls for Hinduism to be brought into this discussion. Would you briefly introduce yourself and then give us your comments from what they call integrative spiritual perspective?
Mm-hmm. I am in Fry University, Department of Religion and Theology, under the chair of Hindu Spirituality and Society. And Zero project, in the previous presentation I mentioned, it has become very special for us. And thanks to Peter Gobis and all the scholars who have really inspired our imaginations. On today's presentation, there were very interesting points that they caught my imagination. And I will start from the reverse order. The discussion on being cautious when we are equating physics with philosophy is a very interesting one, because when atom was discovered, it was named as atomos, which is indivisible. And subsequently, we figured out something more, and then Higgs boson, the God particle, and maybe 100 years later, we will have something else. So it's a moving work in progress, and we are comparing with something which is a philosophy which is of a different nature. That's one submission. Second submission is that in Iceland, there are around 85 words for snow, because they deal with snow every day in and day out, as compared to someone in Arabia. So same way, the philosophies who got to deal with the phenomenon which are infinite or indefinite in nature, so they have more rich vocabulary of representing and talk about zero and infinity. And that has been our point of research. And this further got triggered today when I noticed Professor Jeff Oakes mentioned that Descartes used lengths to represent numbers and not the number line or the Cartesian system, which many may think. So that means that we try to represent zero in certain ways, which was so we were limited in our ways of representations. It can't be said that we didn't have any other ways. So when Peter Kobis said that we were using frequency bars to represent numbers, maybe we were representing counting numbers by those, and zero and infinity by some other means. So these Hindu philosophy and the Buddhist philosophy, there are various gradations of various types of zeros and infinities. For example, in my previous presentation, I mentioned this thing called Adi and Anadi, Abhav and Naganya. So Abhav is the absence of a thing, which is also of four types. Then Naganya, something which can't be counted, also does not exist. So as Icelanders have 85 words for snow, so maybe this Hinduism and Buddhism may have 100 words for zero, and that's the way that they have actually captured or represented this phenomenon. So that was the point. And on Kaspars Klavins presentation, it was very interesting to see that, he mentioned that zero, and also Peter Kobit's comment on Trojan, zero as a Trojan concept going into other philosophies and, creating some kind of disturbances. So when zero came into the monotheistic faiths, so theologically speaking, concepts like fana in Islam is still considered as heretic when it is described in a manner that it is a way to annihilate yourself to become one with Allah. It is still considered heretic. So this is one way that we see that it's not zero in the way that Buddhism and Hinduist philosophy describe, that it's easy to grapple even today. It's not history, it's present. So these are some of the points. And from the integrative spirituality standpoint, I was reminded again of by Marcis' comment that he was presenting to a bank on quantum science, and what is banking has to do with quantum science. So there comes our definition on spirituality, which we gave in one of the papers 2 years back. So the definition of spirituality which we gave in that paper was, it's a quality of becoming aware of connectedness with its existence beyond perceived existence. So for banking, the perceived existence is a certain realm of numbers. So when a quantum person comes in and he talks about the infinite and ubiquitous energy things, which is beyond the numbers and possibilities, so that just triggers their imagination. They inspires them to evolve beyond the perceived existence. Perhaps that's the inspiration, that the spiritual inspiration that a quantum scientist is able to provide to someone in banking, probably. So these were some of the things that I shared. I hope it adds to the discussion that we just had.
But any specific questions that you would like to pose? This is an opportunity.
I would like to ask Kaspars, what are his view on fana, in Islam, because after zero was it before zero came to the Arabic world, or was it after zero came to the Arabic world?
Thank you so much. Approximately the same time when zero came, because fana is being used in a Sufi expression. That's certainly a Sufi expression, and to unify with a god, actually it corresponds in a certain way also with the European mysticism, to be one with the god. That is a base of all kind of mysticism, so as so-called mysticism. At the same time, Sufism in essence was also closely related towards Islam, and but the heretic part is that I am unifying myself with the God, and not just stressing that God is above everything. And it's actually, I'm still unifying, but not in that way that, as Mansur Khalaj told, I am the God. So that's the heretic. But as you rightly told, I think that really the danger is, and as you told, and as Professor Roy told, and also again coming back to Professor Auzinsh and to the physics, the danger is that there are many theories uniting with just as it is one theory, because there are many Buddhisms. Nagarjuna is a very late stage of Buddhism that has very little to do with the Buddhism when it originates, and the Buddhism in Japan and whatever, and Kanon and Avalokiteshvara, we can say that's not a Buddhism, although we are talking it is a Buddhism. Second, if we are checking, for example, the opposite side and mathematics, and I'm not talking about mathematics, but about European mind, for example, alchemy, that was related with the modern science. It is also in many ways told that alchemy is some kind of Western religious esoteric, although it has nothing to do with it, because at that time there was no another terminology as religious in order to legitimize the idea. But also we can talk about many ideas that actually not, there is no one European mind as there is no one Eastern mind. There are many, for example, from Democritus, in a Democritic philosophy, there is emptiness, tokenon, between the atoms is an empty, so-called empty space. But that emptiness has nothing to do with the religious idea of nothingness. These are absolutely two different areas. And if we are mixing these theories together, it's sure that, let us say, we cannot unify them as, let us say, as a one theory. And that's why I think is very good that also many specialists from different type of and different kind of areas are there. And also very important, the exact proof with the atomic, not only also with the, let us say, with the physics and mathematics and all the sciences, because otherwise, even the natural number, so zero is a natural number, immediate successor of any natural number is a natural number. That's, of course, that's a theory after that in a mathematics, but that has nothing to do with the theory before that. So sorry. Thank you so much once more.
Okay, Kaspars. The message is clear. We've taken it on board. It's part of our genesis. We're not going to do that, and we should guard against that, and we will. So, but thank you for reminding us, and thank you, Puneet. I still think in future there should be some scope for the question that Kaspars posed, whether there was any connection to our knowledge or that can be traced through research that you and your colleagues might be able to do between Hinduism and Islam at that particular juncture. I mean, apart from the fact that the numbers were carried to Baghdad, other things would have been carried to Baghdad, and this would have happened even 1,000 years before, when all these different faiths would meet across that whole swath of land between Europe and Asia. So there's some scope for research for the people who are proficient in these ancient dialects, the ancient languages, to see whether there's any hint of evidence that might point to that connection. That's the transmission angle of it, whether zero was independently invented in all these places or whether there was transmission between these nations, between these regions. So these are all questions that complicate the Zero Project, but we're undaunted. We move ahead, and we have on board one of our knights in shining armor, Professor Mayank Vahia, who is undaunted and will tackle any question. So Mayank, you've been patient. You've heard all of this. Please, your verdict.
Yeah, no, that was an interesting session. I want to talk about physics and zero. I think the point was made that quantum mechanics originally started with the idea of zero and showed that zero also has finite energy, and therefore there is no absolute zero in that sense. But there are absolute zeros in physics which are equally beautiful. One is, of course, the absolute zero of temperature. So we have minus 273 degrees centigrade as an absolute zero of number. That even at that level, there is some energy in the system, etc. is a different part of the story. The second point I want to talk about is the physics. The photon, the light photon, has an absolute zero energy, zero mass, as far as physics is concerned. So there are 2 or 3 very interesting zeros even in physics, and these have come, of course, from purely measurements and the Planck's example that you gave, etc. So there are interesting zeros there. The second point I wanted to make is that for somehow, while India's spiritual studies have been well documented, the secular aspects of Indian studies are not well understood. And one of the books that I want to talk about is Vaisheshika, which actually talks about this idea of dividing matter into smaller and smaller matter until infinity. And then the argument goes that if it actually goes to, you can infinitely divide, then you should in principle be able to make Himalayas just by breaking a piece of stone. And that doesn't make sense. So the author of Vaisheshika, 2nd century BC, actually makes this point that there is something smallest that he called Anu, and he gives it properties which are very different from the atomic physics. So the association of the word Anu to atom is a 20th century deviation, if you wish, but the original idea from Vaisheshika is also the same one, that you cannot infinitely divide things, and therefore there must be some limit to divisibility. So those are 2 things I wanted to say. That A, that this idea of in physical world non-divisibility is an issue that is also worried about by Indian philosophers, and they come out with a similar idea of a minimal smallest thing. And the second thing is, from the physics side, now we have such firm zeros of mass of photon. The information content in thermodynamics is zero. So there are 2 or 3 very beautiful zeros. The null balancing, of course, is a local dynamic effect, and you can sort of imbalance systems, etc. And it also has come out with this beautiful concept, as was pointed out, that quantum mechanics begins with the idea of zero, and then realizes that even zero is not null. Vacuum is not null, because vacuum fluctuates within the Heisenberg's uncertainty principle. And that, I think, is an important point. But physics also has other zeros which are absolute. So physics has this dichotomy.
Mike, any specific questions for either of
No, I don't have any. It is just that I would have liked Marcis to comment on the other zeros of physics. And yes, and right. I would have also liked to have something to talk
why
about.
I mentioned it, we'll come back to that, because Victor also has to leave in a little while. We're going to give him a shot at it. Marcis, if you can remember that question that Mayank posed, and then we'll pick it up after Victor comes in, because he has to leave. Victor, again, is knowledge by training and associated with Vrije Universiteit in Amsterdam as well, and on the board, an old friend and on the board of the Zero Project. So, Victor, you've heard the heated debate. What are your impressions? Any questions that you may have?
Well, I must say that as far as the quantum mechanics, I have little to add, because I'm not a specialist on that subject. So I'll just have to take it for what it is. It's very informative to me to hear all this. And I wanted to stress that Kaspars' Klavins paper stresses the need to be very careful in making comparisons, or wide or wild comparisons, and I think I should certainly support that. I think it's methodologically a good way to at least show the fact that many of these philosophical or cultural concepts may not be actually that easily interchangeable. And of course, I hear a lot about the atom, the Indian atoms of Vaisheshika, and also Nyaya Sutra has this concept, which is immensely interesting. But I'll stop here because I have actually nothing to specifically to ask, just to stress the importance of the discussion so far and the caution that one has to take to compare different cultures. Even within one culture, like the Indian culture, like whether you have a Buddhist concept of shunyata, I think there's nothing really comparable to this, even in Advaita Vedanta, even though they seem very similar, but they also have, they're fundamentally not the same thing.
Okay. Thank you very much.
Yeah.
Victor, the way I was introduced to Victor's, I got to read his PhD thesis, which is on Buddhist logic, which is very interesting, and which actually is another subject that we will revert to because it may have carryover value. Apart from the philosophical concepts, which may be hard to transfer, logic would be more logically transferable to other cultures who may not be familiar.
Yeah, there I would actually say that I showed it already, that the Aristotelian syllogism, indeed, in the old Nyaya or even Charaka Samhita syllogism, which was further developed by Dignaga and Dharmakirti, do seem to really point to the same technique. Ultimately, it brings the same kind of knowledge also of the outer world, I think. So there, Aristotle and Indian logic would seem to be, to that extent, very comparable.
But also because there are many logics in India, whereas the West seems to have been hamstrung by Aristotelian two-value logic, which got them a long way, but also got them into difficulty because the world is not black and white, and you would have to expand. It also makes sense that it would anchor you in the empirical world logically. If you look only at things in black and white, either it exists or it doesn't exist. It seems to confirm a bias towards empiricism rather than other ways of looking at things. So that's why I think also one of the things we're exploring is to see whether the underlying logic, if again I stress if, and don't forget the invention of the zero arises in India roughly contemporaneously with the prevailing Buddhist philosophy, and so it may be a coincidence, or it may be that the intellectual climate was prepared in part by that, and no doubt Hinduism, because Buddhism is related to Hinduism, also in the sense that the word shunya and shunyata are related. If there is a connection between the underlying logic in Buddhism, which is a fourfold logic, a fourfold denial, as compared to a simple two-value logic, and then let's not forget the Jainas, who have a sevenfold logic. There are a lot of different logics, and it's good that itself opened up the field, and modern mathematics recognizes that there are an infinite number of logics, depending on your assumptions. So this connection between cultures has opened up the world to everybody. But there too, again, the underlying logic is a definite aspect that we want to explore further in the future. We don't have a super logic specialist on board, but there are reasons to believe that may be fruitful. One of the things that motivated us when we read a paper that was written independently of us earlier than we started by a professor at the Perimeter Institute, which is really top of the line research institute in the world in Canada, who independently wrote a paper on exploring Nagarjuna's logic, and came to the conclusion that a lot of people had thought that Nagarjuna's logic, from the Western point of view, was simply nonsense. It was simply gibberish. It was simply, illogical. It didn't make sense. And his name is Raphael Sorkin. He transposed this into modern symbolic logic, and he came to the conclusion that it very much makes sense. It is not nonsense, and that he even acknowledged that the people that thought of this sort of logic may have had a different conception of a different worldview that we would be well advised to take on board if we want to get further in our own research. So that was totally independently, and there's others. There's a Japanese logician, Nakamura, who compared Nagarjuna's logic with through symbolic logic with modern set theory, in which he concluded that basically the formulation, the Chatuskoti, the fourfold logic, is tantamount to the definition of the null class in modern set theory. Another link between logic and East and West, and possibly the invention of zero, because again, they were contemporaneous pretty much. So yes, all of these are very important inputs. Don't forget, we're being selfish here because we're picking your brains in order to be able to progress with our own research. That coming out of this mix, that we'll be able to put together a research team, PhD students at different universities who might delve into components of this to see whether you can get any closer. And to that end, a little bit of self-advertisement, we're pitching the Expertise Center on Zero to continue on from here, that this should not be a dead end, a book, a conference, and that's it. We want to have this as stepping stones to the research, in which hopefully all of you will be involved in some way, and we will be in touch. We are in touch. We'll continue to be in touch. We revert very momentarily to Mayank, if in case we interrupted you prematurely. Did you have any other comments?
No, I would just like to listen to the answers.
Okay. No, your point was well taken about that zero likely contains more secrets than have been divulged so far. It's been very rich mining the zero. If you think about how far it's brought us, and who's to say that that's the end of the line? Who's to say that there's not more to be found? So we should definitely explore that. I hope, Marcis, that you will be on board with us as an experimental physicist to keep us in the here and now and in the empirical world, but at the same time to look beyond the blinkered view of the modern worldview, because the modern worldview might itself be overturned, like Copernicus overturned. What's his name? See, he's already been overturned. Okay, so thank you again. Let me now go through the usual drill, because we do have, this is the penultimate session, 23. 24 will be the final session, unless we are able to reschedule some of the other speakers who had to cancel out for one reason or another. So, well, I don't know if there's time for that. We'll skip it this time. You know, one of the things that we used to do was ask people the question of whether whether zero was invented or discovered, whether the transition between the placeholder and the numeral was a gradual one or a disruptive moment, and finally whether this concept of nothingness or emptiness is profound. We'll let you think about that, and we'll be in touch on that. But for now, thank you again all for joining, and until we meet again, I'm sure. For now, we'll speak to the virtual audience by saying that the week after next, we'll be welcoming another guest. That'll be Professor Sudeep Bhattacharya at the Tata Institute of Fundamental Research in Mumbai, India, a younger associate of Mayank's who pointed him in his direction. And he will talk about his views of zero, its invention, but also possibly in his own field, which is astrophysics, I believe. So until then, thank you again.